Okay, so in an example problem like this, I'm going to show you two different ways you can go about solving it that will review some of the stuff Ms. Prater talked about in the whole to part video for moles. So what I mean when I say whole and when I say part. Whole is always the whole compound, the whole molecule. So we'd be talking about something like the calcium nitrate itself. So when I say whole, I mean calcium nitrate in this particular example. When I say part, I can mean any part of the calcium nitrate. So I can mean the calcium, I can mean the nitrogen, or I can mean the oxygen. You're always going to be given, you're almost always, for now, especially with distance learning, going to be given the moles of the whole. Sorry, not the moles of the whole, but information about the whole. Like in this case, we are given 30 grams of the whole of calcium nitrate. Depending on what you're given and what you want, these whole to part relationships, if you have grams of the whole, you can go straight to grams of the part. If you have moles of the whole, you can go straight to moles of the part. And if you have molecules, which is always of the whole if we use the word molecules, the part version of that, like you can have molecules of calcium nitrate, you could have atoms of calcium, nitrogen, or oxygen. So I'm going to put a big bold line on here because I think it'll help show the difference of when you can do what. There's a difference between when we're going from grams to grams versus when we're going from moles to moles or molecules to atoms. When we're going from grams to grams, that's when we're going to use percent composition. And so you can go back and rewatch the percent composition video. You have choices from there. There was the proportion or just multiplying the percentage out. But to go from grams to grams, we're talking about percent. Oops, I started writing percent again. Percent composition. Whereas when we're going from moles of the whole to moles of the part or molecules of the whole to atoms of the part, all we have to do is multiply by the subscript. So in this particular question, I have grams of the whole. I want moles of a part. That's not something I can do right away in one step. The easiest way, I think, especially because earlier in the quiz you had already found moles of the whole thing, I think the easiest way of going about this is saying, well, I have grams of the whole thing, so I can find moles of the whole thing as long as I use molecular weight of the whole thing. Anytime we're using that grams equals formula, grams equals moles times molecular weight, the grams, the moles, and the molecular weight all have to be of the same thing. So in this case, since I have the grams of calcium nitrate, I need to use a molecular weight of calcium nitrate. Calcium is 40, 2 nitrogens that are each 14, 6 oxygens that are each 16, I did that wrong in my calculator. I get 164. So when I do 30 divided by 164, what I have found the moles of, I got 0.183. Again, I used grams of calcium nitrate. I used molecular weight of calcium nitrate. So these are the moles of calcium nitrate. Going back to the question, if they want moles of nitrogen, now I have moles of the whole. I can multiply by the subscript to get me moles of a part, in this case, nitrogen. Nitrogen has a subscript of 2, so I'd take my 0.183 and multiply it by 2. .365 would be my moles of nitrogen. That's my answer. I can show you a different way of doing it if you really prefer using the grams formula for this. Hold on a sec. I did all my recording or my erasing with the recording paused. So a different way of going about this, if I want to use the grams formula, again, remember, if I want to use the grams formula to find the moles of nitrogen, I need to use the grams of nitrogen and the molecular weight of nitrogen. In this question, I'm not given anything just about nitrogen, so I'd still have to do some other step first. I have 30 grams of calcium nitrate. I can go from grams of the whole to grams of the part using percent composition. I'm going to do that really quickly because if you need a review of percent comp, just go watch the percent comp video. Calcium nitrate, let's see, nitrogen was 28 of the 164. So that means that we have 17% of this is nitrogen. So 17% of the 30 grams is my grams of nitrogen, which is 5.12. Now I can use the grams equals moles times molecular weight because grams of nitrogen equals moles of nitrogen times molecular weight of nitrogen. If I just asked you what's the molecular weight of nitrogen, you'd say 14. We're not doing N2 anymore. By doing the percent comp, we've already taken into account the fact that there are 2 nitrogens in this compound. So if you're ever using this formula for a part, a singular element, the molecular weight is always just for one of that element. You're not using the subscript there. The reason I don't teach it this way normally is because then it gets confusing on memorizing when don't I use the subscript. That's why I prefer the way Miss Prater taught it and the way I started this video with. So 5.1 divided by 14, we end up with the same answer for moles of nitrogen. I think I got 0.366 this time, rounding differences. That's it.